Hey guys, welcome back to another video from the channel LearnFromBasics. This is Joe here, and this is our third video on the series on this channel where we learn about data structures and algorithms. So in our last couple of videos, we started to basically solve some simple LeetCode problems using simple algorithms such as arrays, lists, and etc. And then we also implemented them in Python. But from today's video, we're gonna get deeper, and we're gonna learn about things such as data structures and algorithms. So I hope you guys know what data structures are, and I hope you guys know the basic data structures such as pointers, integers, strings, lists, and arrays. Now in this video's implementation, we'll implement the current data structure, which is a stack, in C++, but there's also a video if you want to implement it in Python. But without any further ado, let's get started. So what is a stack? Well, a stack is a data structure in programming languages that represents a real-life, stack. As you can see, you can use a stack in programming languages to represent real-life stacks, such as a stack of books or a stack of papers, as you can see. So the stack data structure actually follows something called LIFO, which means last in, first out. What does last in, first out mean? Well, the last element that you input whenever you're declaring or writing a data structure will be the first element that you get whenever you're reading a data structure. So that's basically what last in, first out means. And now if you don't understand what that means, then we'll get into that in a second with this animation of how stacks work. So per se, this is a theoretical stack. This over here is a stack. And as you can see, it's kind of like a bin where you can stack a bunch of elements. And these orange boxes are integers. So as you can see, right now in our stack, we have two integers, 1 and 7. So because stacks follow LIFO, this first element, or element number 1, was the first element that you put into the stack. But now, do you see how it's the last element in the stack? So it's the lowest element in the stack. So the first element that you put in the stack is the lowest element in the stack. So the earlier you put in an element into a stack, the lower it will be. So what operations can you do with a stack? Well, as I mentioned, you can add stuff to a stack. You can add elements to a stack. So if I wanted to add this element, if I wanted to add 45 to the stack, I would simply use a function to add this element to the stack, and we'll learn about what that function is, but you can add elements to the stack so as you can see, I added the element onto the stack, and it's on top of our previous element. And then I can also add minus 12 to the stack, so you can add stuff to the stack. You can also read the highest element of the stack. You can read the topmost element of the stack. In this case, if I wanted to read a stack or read the topmost element of the stack, I can ask the stack, hey stack, what's my topmost element? And it's going to return the number 12, or in this case, minus 12. So now, do you see how LIFO works? So last in, first out. So the last element I put into the stack is minus 12, but do you see how the first element I can read is minus 12, so that's why it's last in, first out. So the earlier you put in an element, the lower it will be in the stack. And the later you put in the element, the higher it'll be in the stack. So I hope you guys understand that. So as you can see, this is stack and its implementation. And you can actually also delete stuff in stack. So but whenever you delete stuff in stack, you can only delete or pop the topmost element. So I can pop minus 12. As you can see, since minus 12 is the top element. But in this scenario, when a stack is in this state, I can't pop the first element or any other element. I can only pop or delete the top element, as so. So that's the implementation of stack. Now let's talk about time complexities. Let's talk about time complexities of adding, removing, and getting the top element of the stack, and also learn about what functions can be used in a stack. So without any further ado, let's look into that. So, in our last part of this video, we talked about the theory behind the stack. Now let's talk about all the methods and the big O notation, or the time complexity of those methods. So, you can actually implement a stack, or you can create a stack using arrays or linked lists. But I think the most efficient and easiest method is to use an STL in C++, or the standard template library. Of course, it's a different method in Python, and we'll look into that later. But for now, let's focus on C++. So in C++, when you're using a stack, you can use all of these functions. You can use the push function, which allows you to add or push an element onto the top of the stack. You can use a pop function, which will allow you to delete an element off the top of the stack. And finally, you can also use the top function, which will allow you to retrieve the topmost element of the stack. And all of these take in big O notation of O of 1, which is the best time complexity possible. And then you also have the if is empty function, which basically tells you whether the stack is empty or it contains elements. This also takes an O of 1 time, which is also great. So these are all the methods of a stack. Now let's look into the implementation of a stack. Okay, so in our last part of this video, we learned about what functions are in a stack and their time complexities. And in this part of the video, we're going to learn the implementation of stack. Now for this video, we're going to implement stack in C++, but in a later video, we'll also learn how to do that in Python. But let's focus on C++. Now in C++, you can implement stacks using 3 methods. You can either use a linked list, an array, or an STL. Now I recommend using the STL implementation of a linked list because it's fast and it can save you a lot of time when it comes to competitive programming contests, as an STL is basically a pre-written library for data structures. Now you might be wondering, well, can I use STLs during my competitive programming contests? Well, you can actually use STLs in many competitive programming contests, and they're the norm. So you can use STLs. It's no problem, and these don't count as pre-written code. It's just a standard It's just an STL, which is universal. So you can use STL implementation of multiple data structures in your competitive programming contests. So, for today's video, we're just going to use the STL implementation of a stack. So what is an STL? Well, an STL is a standard template library. It's basically pre-written code or a template for a data structure. So it has a template of the data structure and all the functions in a data structure. In this case, the developers of C++ have already written the code for all the functions that will be needed for a stack data type. So instead of rewriting these functions, we can just reuse that by importing that function. So we can import the function, we can actually hash include, and then first of all IOStream, because of course we need IOStream. And then also we need to include the STL or the STL of our stack. And there are actually multiple STLs for different data types such as vector, array, and etc. But as you can see over here, we have an STL called stack, so we can simply import an STL stack. So now that we have that out of the way, the next thing we're going to do is, again, set up our basic code using namespace std. And then we also want to write the int main function. And again, you guys will need to know some basics of C++ for this. So now we have the int main function. We have our basic code written over here. The next thing we're going to do is we're going to declare a stack. Now you can declare a stack in C++ using the STL method. You can declare a stack by first of all saying stack, which is the data type, less than symbol, and then over here you want to give the data type of the values in a stack. In this case, I want to put integers, so I'm going to say int, but you can say char, strings, or etc., etc. And then close, and then we give a name to the stack. Let's just say numbers. And now the next thing we can do is we can push elements onto the stack, as we discussed last time. Or we can add elements to the stack. So if we want to add elements to the stack, we can say numbers dot push. And it's not push back or push front, just push. And then we say a number we want to push. And then we can do that multiple times. So how about we say 11, 12, 13. And remember, stacks are not sorted. And And now the next thing I can do is I can print a stack. So you can actually, there's no function to print a stack. You can just create a function to print a stack. So let's go ahead and do that. Creating a function to print a stack is pretty easy. So over here we can say void print stack, and then we can say stack of int print stack. And then what we can do is we can print the stack until we can so this is how we print the stack. You have a stack, right? For example, 1 2 3 4 5, with this being the topmost element of the stack. So how you print a stack is you first of all duplicate a stack, and then you take the topmost element of the stack, print it, and then pop that element. Pop, you may wonder, what do you mean by pop? Well, we'll look into that in a second. A pop, as you might remember, is basically deleting the topmost element of the stack. So we basically print and pop all of the elements until there are no elements left in our dummy stack or in our duplicate stack. So we can say while print stack, well, print stack is not empty, so that's why print stack.empty is false. That's why the not symbol. And then we can again see out print stack.top, and then let's just put a space. And then we can say print stack dot pop. And again, pop deletes the topmost element of your stack. And dot empty tells you whether your stack is empty or not. And then at the end, just for aesthetic purposes, I guess, we can just say cout endl. And then over here, we can print stack numbers. And then let's run our program. Oof. Okay, yeah, forgot. There. And I'm pretty sure it's not just, I'm pretty sure you have to put, yeah. So now as you can see, we have our stack printed. And now, again, as you will notice, whenever we print a stack, the first element of the stack is the last element we added to the stack. Again, LIFO, last in, first out. And then if I want, I can actually numbers dot pop. So you'll see that 15 is not there anymore. So we can actually do that after and print stack again. Print stack numbers. And then as you can see, we popped 15. So that's basically a very basic implementation of stack in the C++ STL. So whenever I learned data structures, I always wondered, well, why do we use this? And that's a great question. In fact, we'll solve some important problems and we'll see how stacks can be used in real life in our next video. But that's all for this video. I hope you guys learned something new. Again, if you did like this video, don't forget to like, share, and subscribe. That's all for this one. See you guys in the next one. Bye-bye.